So let's see the porous pot experiment. So a porous pot is a container that has small pores through which gases or liquids may pass through. So it's a container with tiny little holes into it, which means that molecules of liquids or gas can go through. So this is called a permeable layer. Now, this experiment consists of a porous pot which is surrounded by a beaker, and inside the beaker you have gas Y. So you have gas Y in red here, and then you're going to have another gas X that I'm showing in blue, which means that gas Y will be able to get inside the pot while gas X will be able to go outside the pot. Now, as the gases they are going to move, they are going to create a difference in pressure. So if there is a lot of gas inside the pot, so if you have lots of gas Y getting inside the pot, so you have lots of Y getting in. So lots of Y getting in means that the pressure inside the pot over here is going to increase. If pressure increases, it pushes this liquid down. So this is going to be water normally, or any inert liquid, means an unreactive liquid. So because of the pressure, it pushes down the level of the liquid. So it's going to push down. And if it pushes down on this side over here, which means that on the other side, it's going to move up. So you have on the right hand side, the level of liquid moves up. Now, if there is another scenario where there's lots of gas that leaves the porous pot, so you have all the gas X getting outside, so there is less gas X inside. All right, so you have all the gas X outside, and then the gas Y takes time to go in, so it stays outside, means that the pressure inside the pot is going to decrease. Here, there's a decrease in pressure, so there's going to be a suction motion set up because the gas is leaving the gas jar. So you have the level of liquid goes up on this side, therefore the level of liquid goes down on the right hand side. Now, if ever the two gases move at the same speed, at the same rate, then there is no difference in pressure, so the level of water, the level of liquid here does not change. It stays the same. Let's see this in action. So in this case, we have nitrogen gas outside, nitrogen gas N2, carbon dioxide gas CO2 on the inside. So nitrogen, if we look at the MR of nitrogen is 2 times 14, so it's 28. And the MR of CO2, it's 12 plus 2 times 16, so this is 44, right? Nitrogen has a lower MR than carbon dioxide, which means that nitrogen gets inside the pot much faster. So lower MR, therefore it diffuses faster. Therefore it goes inside the pot faster. Therefore pressure inside the pot increases. And when pressure inside the pot increases, this is going to go down and this level of water is going to go up. So level of water on the right hand side will go up. Right? So question, determine the MR of each gas and which one will travel faster. So we found the MR and we said that nitrogen will travel faster. State what will happen to the level of water at point X. So this is point X. So it rises. Explain what will happen. So explain why, actually, this question should be modified. Explain why this will happen at point X. So this is because nitrogen diffuses inside the pot faster than carbon dioxide going out. Therefore, pressure inside the pot increases. Voila, that would be the answer. So these are the two elements of answers. So you will complete this, and so when you're done, you will try to do case 2. Case 2, you have carbon monoxide, CO, and you have nitrogen, N2. So you will find the MO of these two here, and you will say what will happen to the level of water at point X. So this is X here, and you will explain why this will happen. So this is case 2. Case 3 is this one. Case 3, you will have a little modification to make. Actually, the hydrogen is inside. So hydrogen is H2. Hydrogen is inside, and the carbon dioxide is outside. So it's not inside the pot. Carbon dioxide, CO2, is outside the pot, right? So you will find the MO of these two, and you will say which one travel faster, what will happen at point X, and explain why this will happen. All right, so we finish at case 3. I will be checking this when we are back to school.